So in this lecture, we will see one of the most important process of plant maintenance, which is called as a calibration process. Now, first of all, we should understand what exactly the meaning of this calibration. See, whenever you want to use any sort of measurement instrument in your process, so your first duty is to ensure that whether that measurement instrument is working perfectly or not. Now, in order to check the perfectness of the measuring equipment, we generally go for a calibration process. So it is a periodic calibration process. Suppose you have a temperature gauges, you have a pressure gauges, you have a different type of flow meters in your factory. Now, whether this temperature gauges, pressure gauges, and flow meters are working fine or not, to check their performance, we go for a calibration. Okay, so plant maintenance calibration order is a plant maintenance special order that tests whether the specific piece of test equipment fulfill the performance criteria or not. See, sometimes calibration and condition monitoring can also be clubbed. Okay, because in calibration process we have a certain guideline. We want to make sure that your instrument is working as per guideline or not. And in condition monitoring also, we go for the same thing. We have some condition, and we want to check whether that condition is deteriorating or not. So this type of thing comes under the calibration or condition monitoring. Now, first of all, to check this condition monitoring and calibration, what type of data you needed? We have seen in case of a preventive maintenance, we created a plant maintenance plan. In case of a breakdown maintenance, we created notification, then we created order. So primarily our process will remain same, but the difference will be in terms of one more addition. Here, for the calibration purpose, PM module gets integrated with other module that is called QM, quality management module. Okay, because all the parameters of your equipment or machine or instrument can be created as an inspection characteristic, that characteristic which you want to track. So for that purpose, we are going to use the QM module. And in QM module, there are different type of inspection available. Few inspections are carried out for raw material. Few inspections are carried out for semi-finished or finished product. In the same line, there is a one inspection type called 14, inspection type 14, which is used for our calibration purpose. So what details you need or what master you need? So primarily, as I said, it is a calibration is a mixture of a preventive and the QM. So if we talk about the calibration, so here on a PM front, we need primarily master, like what equipment we want to calibrate. So you need equipment master. Then how this equipment is to be calibrated, that we consider under the task list, right? So that task list will be common in nature, and your integration between QM and PM is done with the help of task list. Now you have equipment master and task list. As I told you, the calibration is a scheduled job. You need to perform this calibration periodically uh, in a 15 days or in a 1 month or 3 month. It is as per the manufacturer's suggestion or the guideline. So for that purpose, we need another, for automatic scheduling, we need maintenance plan. Then we need maintenance plan schedule. However, on QM side, we need, first of all, we need one master inspection characteristic. Master inspection characteristic. The master inspection characteristic is a characteristic which you want to check, which you want to verify whether that characteristic is performing as per your guidelines of the manufacturer or not. Then this master inspection characteristic, after that, as I told you that here, this is integration between PM and QM. So in QM, in order to check any master or any type of equipment, we create one inspection lot. This shall be generated automatically, and after that we need to perform result recording. Result recording is putting actual result in our system. Then last one is called user's decision, whether that equipment or instrument what you have checked is performing well or not. You want to continue its uses in your factory operations or not. So which is called user's decision. Either you can accept that instrument for uses or you can do rejection. Now here the integration works in this way. Your master inspection characteristic shall be a part of a task list, and when you have a maintenance order in hand, when you plan or when you schedule the maintenance plan, you will get one maintenance order like we have seen in case of preventive maintenance. So along with the maintenance order, you'll have a maintenance order. So along with your maintenance order, you'll have a one inspection lot. So in this way, this will be connected. So I'll do one thing. I'll quickly go and I'll create the required master setup for the calibration purpose. So here I'm creating one pressure gauge. IE01 is a T code for equipment creation. I'm putting description as a pressure gauge, and all other details shall remain same. For calibration, there is no any specific requirement from for the as far as the equipment master is concerned. Here you can put indicator ABC, whatever you want to do. And Bradley is the manufacturer. Then I saved it. Okay, so this is a equipment master which I have created. Let us copy this number. Equipment master. Now we will create one task list. Okay. Prior to this task list creation, let us understand what exactly this master inspection characteristic. So master inspection characteristic is basically a characteristic which you want to check. Now I have a few characteristics which I have created. So let us go through all those characteristics. So you can go to logistics under quality management, then quality inspection, sorry, under basic data, here inspection characteristic. Okay, so inspection characteristic is also called as a MIC. So first of all, it is a plant dependent master. Then validity date, you can give any name for this. Let's say I'm giving name as a test. Now see, either a characteristic can be a quantitative characteristic or qualitative characteristic. The meaning of quantitative and qualitative is that in case of a quantitative characteristic, you'll have something which is to be measured in terms of a number or in terms of a quantity or in terms of a, when I say quantity, it doesn't mean it is only relevant to the weight. It is anything which can be measured at absolute number. Okay, like your weight, distance, movement, time, all these are a quantitative characteristic. However, We have also some qualitative characteristic. Qualitative characteristic means quality is good or bad, whether material accepted or rejected. It is subjective in nature. So for calibration purpose, we are going to use quantitative characteristic. Here, one important thing, your characteristic must be released. Then description of a characteristic. Let's say I'm giving description as a pressure. Okay. This is here. In order to make your search easy, you can also give some search field. Now, as I press enter, every characteristic will have something to check. See, this is a quantitative characteristic. So when you want to compare anything, so let's take example of weighment. Suppose you have a one weighment scale. So there would be some range from 0 kg to 200 kg. Okay. It means 0 is a lower limit and 200 is upper limit. So either you can use this combination of 0 to 100 if your characteristic is in the range, then you have to select lower and upper both. And if your characteristic is not in range, it is the exact target value. Let's say my pressure should be 50 bar. Okay, now this 50 bar is a target value. So in that case, we need to select the check target value. And apart from that, here we have a sampling procedure. See, sampling procedure is primarily a one application under the QM management which talks about how the sampling is to be drawn. Okay. Then also here we have another thing which we called is inspection scope. Whether this inspection scope is fixed in nature, it can be variable, it can be fixed from here. Record measured value, it means whatever values you are gonna enter in the system, that value should be recorded. Okay. So these are a few primary thing. Okay. I'll tell you one thing. I'll open my characteristic which I have already created. I have assumed that our calibration will work in this way. I have created a characteristic called 0%, which says pressure at 0 kg. I want to calibrate a pressure gauge. Okay. And in pressure gauge, I want simply to calibrate. I'm gonna put some pressure. Let's say if I'm not putting any pressure, then what is the value of my pressure gauge? It must be 0. Okay. If without putting any pressure, your pressure gauge is showing some value, let's say 0.1 bar, it means there is an error in your pressure gauge and you shouldn't use this pressure gauge. So now what you can do, you have to correct that pressure gauge with the help of instrumentation technicians. Okay, so I have created three different characteristics: 0%, 50 and 100. So let us do one thing. Let us go to the next master, which is my task list. As we know that task list contains a list of operation to be done. But here, the role of task list is not only to monitor the list of operation, but here the task list act as an integration point between QM module and PM module. Okay, so new task list, key date, because a few details we have already shared during the task list part. Here I can put a pressure gauge calibration. The name, my planning plant is PM01. Everything will remain same. Your uses 4, which says task list is for this particular task list is for plant maintenance, planner group, the person responsible for this task list, status, whether this task list is to be in what stated. It is in creation phase, for release for ordering, release for costing, release general. Okay. When I say release general, it means this task list can be used everywhere. Okay. If I say release for costing, it means that task list can be used for costing only, not for ordering and other purposes. Here we have a maintenance strategy. So if you remember, we have created one strategy called PM. This maintenance strategy controls the frequency of maintenance, schedule of maintenance, monthly, 2 monthly, 3 monthly, 6 monthly, yearly, in this way. Here, for the purpose of calibration, see here we got a one option called QM data. See, in QM data, whenever you want to perform any calibration, so the first integration point is an inspection point. Inspection point is a one variable. That variable can consider the information about the equipment. Okay, so I'm putting a, now I'm going to the operation overview tab. So here I'm simply putting my description, because here I'm not going to perform oiling, greasing, all the work which I have done in preventive maintenance. Here my objective is simply to calibrate, and what should be the frequency of calibration that can be given with the help of maintenance package here. Okay, so here I selected maintenance package as a monthly. Now for this calibration purpose, what are the inspection characteristic I want to use? So to assign the inspection characteristic, you need to click here, inspection characteristic. And here you can put a inspection characteristic. Let's say I'm putting 0%, 50%, and 100%. Okay. Now, what is this? What is the meaning of this 0%, 100%, and 50%? So this here we have used 0%, 50%, and 100%. So meaning is that if I'm putting 0% pressure, then my target value, the meaning of target value is deflection in pressure gauge. It should be 0%. If I'm putting 50 kg pressure in second characteristic, then the deviation should be 50%. Okay, the half of the dial of pressure gauge. If I'm putting 100% pressure, 100 kg pressure, sorry, then my deviation should be 100% of a dial. So this is I want to check. So I'll save this 87 number. Now let us go and create a maintenance plan, because maintenance plan is a primary requirement. So here we have a maintenance plan category. We can create a separate category for calibration purpose. Strategy, we are going to use same strategy. I'm giving calibration of and we have our equipment number here. This one. See, the maintenance plan creation will remain same except one thing. Earlier, in case of preventive maintenance, we have used order type called maintenance order. Here, we have to use one order type which is a calibration order, because a calibration order must be assigned to the inspection type. Okay, I'll show you. Okay, so I'm going to SPRO setup, where I'm going to brief you about the calibration order setup. Under the SPRO, in plant maintenance, maintenance and service processing, here we have a maintenance and service order. So first thing is that function and setting in order type. So configure order type. See, you can create new order type as per your wish. The order type creation is pretty simple. You have to give one order type number, then the description of order type, and other details like CO partner update. It should be always considered as semi-activate. CO partner update make a relationship between CO module, controlling module, and PM module. Here we have a settlement profile. As you know that whenever you create or perform any sort of maintenance task, so you'll be doing some incurring some cost. So that cost must be settled to somebody. See, this part is not that much needed. So you can, what you can do for any new order creation, you can simply copy any previous order and you can keep other detail as it is. Now this is a calibration order. So how would system know whether this is a calibration order or a regular preventive maintenance order? So for that purpose, here, first thing, assignment order type to maintenance plant. So whatever order type you have created, that order type must be assigned to your maintenance plan. So our maintenance plant is PM01. So you can see in PM01, we have assigned these many order types. Okay. This is relationship between order type and plant. And the most important thing, assign inspection type to maintenance order. Now see here, calibration is a kind of inspection. Okay. And our calibration order is PM06. So for this PM06 order type, I have assigned inspection type 14. Now, what is the inspection type 14? Inspection type 14 is the one default inspection type provided by SAP, which is to be used for calibration orders. Okay. Later on, when we move forward, I'll tell you what is the role of the inspection type. Okay. So remember, your order type must be assigned to inspection type. Here you can see all other order type like PM01, PM02, PM03 has no inspection type. It means these orders are not calibration order. For calibration order, it is mandatory to assign an inspection type 14 to your order type. I'm again going back to the plan part. Okay. And here we have created one 82, I guess. Task list, right? Under the scheduling parameter, you can know scheduling period, for how long period you want to schedule this order, and completion requirement. Once the first order is completed, then only system shall generate a new order. This is the one requirement. See, there are two approach. First approach, suppose you have a maintenance schedule in every month and you want to run the schedule for whole year. So one approach is that system shall create 12 orders directly. Another approach is that in the month of January, system will generate one order. If that order is satisfied or closed, we have performed the confirmation, we have done the technical completion, then only the next order shall be generated. Okay. And if you want the second approach, then this completion requirement tick is mandatory. So now I have created maintenance plan. From where you want to start the cycle. So I'm putting 1 month old date. Okay. Now this maintenance plan need to be scheduled in the same way what we did for preventive maintenance. Simply go to IP10 and click on the start cycle, give the date, press enter. So you can see here we have all orders, schedules. Now when I save this, system shall generate maintenance order for me. Now to check that order, you can go to IW38. There, your order type is PM06 for calibration. I'm also entering my plant PM01. and let us execute it. So it is showing me two orders. Okay. The second order belongs to us because this is equipment number 7227. This order belongs to 7227. So I simply open that order. See, currently the status, we have observed that here we have a new status called ILAS. What is the meaning of this ILAS? Let's search. Inspection lot assigned. So what we did in the configuration, we have assigned inspection type 14 to the calibration order. Now, when we schedule the maintenance plan, so that schedule triggers two functions simultaneously. First, that schedule create the maintenance order here. Another thing, that schedule also creates one maintenance along with the maintenance order. That schedule also create one inspection lot. Okay, and that inspection lot belongs to 14 inspection type. Okay, if you click here, you'll see the inspection lot number. See, this is inspection lot number, right? Now, I'm just copying this inspection lot number. Now, suppose as an instrument person or field person, you'll simply go to QA32 transaction. Okay. In QA32 transaction, you want to check how many calibrations are pending in this month. So enter your plant number and inspection type 14. Here you have a three options: select all inspection lot, select inspection lot without usage decisions. So I'm considering select without usage decision. Now see, I have a two orders. I have a two inspection lot here. Here, if you go and see the system status, one status says RREC INSP, means result recorded and inspected. It is a one old order. Okay, this order is not belongs to us. This is an inspection lot which belongs to us. So here you can see the current status says released. It means now you can use this inspection lot. So as an end user, I have performed the pressure gauge calibration in live. I have put 0% load and I have checked what is the value. I have put 5 kg load. I have put 10 kg load in this way. So whatever your observation were, you have to enter here. So select your inspection lot, click on result. This particular pop-up is due to the inspection point, what we have entered in our task list. It simply says that this inspection lot belongs to which equipment. This is the same equipment. Now see, this much we have created during our task list. Pressure at 0 kg, pressure at 50 kg, pressure at 100 kg. And here we need to enter our actual value. See, when pressure was 0 kg, the deflection was 0. When pressure was 50 kg, the deflection was 50% because I have given here unit of measurement as a percentage. At 100 kg pressure, deflection was 100%. It means this particular inspection or calibration is accepted. Now you can use this equipment or pressure gauge for your further inspection plan. So remember, there are two things. Along with the maintenance order, you'll have an inspection lot. You need to enter the actual results, your actual observations in inspection lot. And your system can automatically suggest you simply select it all and click here as a close. So see, if your result is as per the desired specification, system is also proposing accept. You can consider the system proposal or you may change it as a reject. It depends on your choice. Okay. For second one, system is also saying accept. For third one, system is also saying accept. Okay. Now let us save this. Okay. Now if I refresh, see currently the status is released and CLAC. Now I'm going to refresh this screen. See my status changed to INSP or RREC, means inspection done, result recording. Now, after this inspection and result recording, you need to perform the user's decision. User's decision is about taking or recording a decision whether this equipment is to be usable or not. Okay. For that purpose, simply go to the user's decision, and here you can select accept or rejected. A for accept or R for rejected. Okay. And save this. Okay, here no issue here. Selected code is not available. So uh, uh, in this server, so commonly in all servers you will have the selected code as a accepted or rejected. So no issue in that. I'm not doing user's decision, but it is suggested to perform a user's decision. Now I'll show you another important thing. See, the complete objective of this calibration process is not just to make data entry in SAP, but we also want that system should send us some sort of report so that that report can be shown or can be submitted to the auditor, because calibration is one of the favorite topic of all auditors. Okay, so I'm going back and I'm going to show you the report here. So see here, I have selected the inspection lot. I'm clicking on this inspection report. Okay. See, SAP has provided one default SAP script, which is the one format, SAP default format. If you want to develop your own format, then you can develop that format with the help of ABAPer, and you can assign that new format here. This is what I'm going to show you. It is a SAP standard format. So this is a script name, output device printer. See, this is inspection report coming. Inspection report for this equipment, this inspection lot, material as a pressure gauge, because it is a inspection lot. So that's why it is showing as a material. Okay. Origin, plant maintenance. It means this report belongs to the plant maintenance. In plant maintenance, the inspection type 14 is used. Okay. This is a task list description. This is the inspection period, the period for which you have inspected. Okay. Then equipment name, number, the valuation, accepted. Yes, I have accepted the activity. And here you can see these are the three characteristics which we have checked. Pressure at 0 kg, pressure at 50 kg, pressure at 100 kg. So my result was 0% deflection at 0 kg, 50 kg, 50% deflection, 100 kg, 100% deflection. Okay, it means this is a okay report. I can use this equipment for, I can, or even if that equipment is currently in use, so you can continue using this equipment, right? So this is one process about the calibration. Now, what else need to be done in this calibration? See, your order is already in the place. Okay. So we need to close that order also. So for that purpose, I'll go to IW38. Okay. PM06. My maintenance plant is PM01. My order type is PM06. This is the order. So see, I have done all the result recording under my inspection lot. Okay. So in this order, nothing is to be done. So either you can write some sort of comment here. Under the operation, if you have done some job, like suppose your equipment wasn't in good condition, at 50% it was showing wrong deflection. So if you have done any repair work, so you can simply write down the repair work done here under the operation, and after that you'll confirm that operation in the same way what we have done in case of a preventive maintenance. Okay. See, one thing I want to tell you, if you have any, because when you go to the SAP, you'll find lots of challenges about searching the plan number and all that. So see, under this order tab, here we have a planning tab. This planning tab tell us about the maintenance plan number. It means this particular order is generated through this maintenance plan number. Under this maintenance plan number, maintenance item number. What is maintenance item number? Under the maintenance plan number, you can create many maintenance item. Maintenance item means sub plan. Okay, sub maintenance plan. So this order is generated due to this maintenance plan, and this order is gonna use this task list number. 82 is a task list number. Task list type was A category, general task list, and group counter 1. Okay, so you can have this detail in order itself. Okay, now I am doing technical completion because for all maintenance order it is always suggested to do the technical completion. So I'm doing technical completion. Here it is again asking me for settlement rule. I'm giving it settlement rule manually, or you may perform this activity also. Here see reference date and time. Then when I press the enter, system shall save this order. See my status got changed to TechGo. So this was a calibration process in SAP. Remember, it is an integration between PM and QM. These are master data required at PM side. These are a master data required at QM side. And MIC is getting integrated on task list. And on basis of your maintenance plan schedule, maintenance order as well as the inspection lot need to be generated, and your actual result shall be entered in inspection lot. Once your equipment is okay, then you can close the maintenance order. So that was about the calibration process. Thank you.